Hello, ladies and gentlemen. Welcome back. Hopefully you took a little break between videos. Let's continue. We've got one more type of sequence to talk about. This one is called a geometric sequence, a sequence in which each number is equal to the preceding term multiplied by a constant. So geometric is multiplying, and the R is the ratio. That's whatever we're multiplying by. So here's a pattern. All right. So again, we follow it just like in the last lesson. Let me move my little picture here. There we go. All right. So we got figure number 1, 2, 3, 4, 5, 6, 7. In figure number 1, how many shaded triangles do we see? 1. In figure number 2, I see 3 shaded triangles. And in the next one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, well, I've already told you that this one's geometric and that we're multiplying. In the last video, I emphasized that you may not want to write down the pattern right away until you know it, okay? So if I started like okay, now here for real, okay? Let's say I went, okay, this one goes up 2. Don't write that. This one goes up 6. Whoa, that right away tells me, nope, it's not arithmetic. Okay, it is not arithmetic. So that means we've got to try the other thing, which is multiplying. So 1 times 3 is 3. 3 times 3 is 9. Okay, yep. So there we go. So now we're multiplying by 3. And multiply by 3 again. And multiply by 3 again. Okay, and so on. Wow, so you mean if we got to the 7th figure and we kept that pattern, we would end up with 729 shaded triangles. That's crazy. Okay, if you recall, that's exponential. Okay. That's exponential growth. We'll talk about that more later. So why is this one geometric? Okay. We are multiplying by 3. How many would there be in the 8th figure? Well, we would take 729 times 3 more, and we would get 21,800, wait, 2,000, sorry about that, 2,187. Calculator routine, all right, we know about that. Okay, it follows the same type of pattern. We're going to start with 1, enter. Okay, then we're going to hit the time sign, and when we do that, ANS is going to pop up and we're going to multiply by 3, and then we're going to hit enter, and we're just going to keep going. All right, so we want to know how many are in the 15th figure. So here we go. Again, pause at any time that you need to catch up if you're have fallen behind. So again, we're starting with 1, enter, times 3, enter. Okay, that's the 2nd one, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, and 15th. Wow, over 4 million. 4,782,969. That's a lot. All right, well, let's look at another one. Actually, let's continue with that one. So, write a recursive routine for this situation. So, this is how we do it for geometric. Again, we go U sub n equals U sub n minus 1. That should be automatic, folks. That will never change when I ask you to write a recursive routine. It's always those things. Now, since this one's multiplying, I'm going to use parentheses Don't put a times sign there. I mean, you could, but I'd rather you use parentheses. And obviously don't put a plus sign there when we're multiplying by 3. All right, so what's the 16th? How many are in the 16th figure? Okay, well, that means I'm going to take the 15th figure, which is the figure in front. Again, that's the u sub n minus 1 times 3. So that means, ladies and gentlemen, I'm going to take the 4,782,969 times 3. And I'm going to get a whopping 14,348,907. Cool. All right. Next one. So here, notice there's nothing in the table. Oh no, what shall we do? Okay, well, this is again the u sub n. Okay, and then let's see. Oh no, hold on here. My mistake. Let's just do this. Let's just go. Okay, first number is 29. Okay, let's not worry about that other stuff for the moment. We'll do that later. The second number is 18. The third number is 7. The fourth number is -4. So is this arithmetic or geometric? Well, I'm going to start with, I'm going to check to see if it's arithmetic. So first I'm going to see, is there anything I'm adding? Okay, I'm checking. So let's see. Oh, I'm adding a -11. Oh, yep, -11 here too. -11 here too. Mr. Ellering, couldn't you just say -11? Yes, you could just say -11, that's fine. All right, so if I continue, the next number, take away 11 or add -11 is -15. And then -26. So, ladies and gentlemen, it's arithmetic, okay? We add -11. What's the 10th number in the sequence? Well, if I keep going, ladies and gentlemen, okay, I don't want to take up the time to do that because we've done that several times. Okay, if we kept going, we would end up at -70. Okay, fill in the blank. All right, well, that would be 29. We would add -11, enter, 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 and so on. All right, find the 28th number. Okay, I'm not going to take the time to do that. You can use your calculator routine to do that. You get -268. Pause it, see if you can get that on your calculator. Okay, write this out. That would be u sub n equals u sub n minus 1 plus -11. And last thing for the notes, ladies and gentlemen, I want to know the 29th number in the sequence. That means I'm going to take the 28th number in the sequence and add -11. Well, do I know the 28th number in the sequence? Well, yes, I do. The 28th number in the sequence is -268. I'm going to add -11. And like magic, I get -279. So the 29th number in the sequence is -279. All right, ladies and gentlemen, hopefully after these two short videotapes, that makes sense. Again, we learned about two types of sequences. We learned about, okay, let me back up. We did the arithmetic, which is adding, and we did the geometric, which is multiplying. If you have to, rewind, rewatch these videos, and I'll see you soon. Adios. Work on the assignment and get it submitted. Thank you.